Good day, viewers. You are welcome. How to find the value of x in this nice exponential equation where we have 4 to the power of minus x equals x. So, and to solve this, what we consider here first here is we are going to introduce logarithm to both sides. So, suppose we introduce logarithm which is ln 4 to the power of minus x equals ln x. So by having something of this form, the next thing we are going to do here is we transfer negative x, we transfer it to the back of this as we have minus x ln 4 equals ln x. So then we have to divide both sides by x. So we want to make sure that we have only x at one side. So when x cancels x, so here we have minus ln 4 equals ln x divided by x. So on getting to this stage, so I want to rewrite this thing properly by letting this one here and transferring this one to other side. So here we have ln x divided by x equals minus ln 4. So we should know that we have ln x divided by x. So at this side, we can write this as 1 divided by x ln x. So they are still the same thing with this. Then everything equals minus ln 4. So the next step here is, suppose we write this as x to the power of minus 1. So you see the same thing as 1 divided by x ln x equals minus ln 4. So then I want us to know that for the second time, anytime we have e to the power of ln x, so this one is the same thing as x because exponential and ln, they are inverse to each other, so they cancelled and we have only x. So let's say I manipulate this and write this one first, which is ln x. If I write ln x first, then instead of this x to the power of minus 1, I'm going to introduce e to the power of ln to this one. Then we have e to the power of ln x raised to the power minus 1. So everything equals minus ln 4. So getting to this stage, so the next thing we are going to do here is I want to make sure that what we have here the same thing as what we have here. But before that, so we have to apply the rule of logarithm by taking this power which is minus 1, we take it down and we have ln x multiplied by e to the power of minus ln x equals minus ln 4. So next we have to introduce negative here because this one is having negative, so we have to introduce negative for this one to be equal. So we have minus ln x multiplied by e to the power of minus ln x equals, so we are introducing negative here, so which means negative here become positive because we introduce negative throughout, and here we have ln 4. So the essence of doing all these things is because we want to make sure that the coefficient of this one resemble the power of this exponent. And what rules tells us that? So the rule that tells us that is called Lambert omega functions. Suppose we have omega of m e to the power of m. So this is always constant and we have it as m. So we have to consider this thing always, that if you have this function and here we call it Lambert omega function, so the coefficient of this exponent and the power of it must be the same before we can choose m. So looking at this one, minus ln x is the same thing as what we have at the power of this exponent, which is minus ln x. So we can now introduce the omega function, which is omega of minus ln x multiplied by e to the power of minus ln x. Everything equals the omega of ln 4. So if this is what we have at this stage, so we have to choose this minus ln x because we follow this formula. And here we have minus ln x equals the omega of ln 4. We can write it as ln 2 to the power of 2. Alright. And from here we have minus ln x equals omega of, so by rule of logarithm, we can take these 2 down and we write ln 2. So for the second time, I want to make sure that I want to have another Lambert function here. We have 2 ln 2, which we can introduce exponential and ln to this 2. Then we have minus ln x equals the omega of, we can write this as ln 2, then multiply by e to the power of ln 2. Because when this cancelled, we also have 2 again. And this also follows the rules I applied above, which is the omega of m e to the power m equals m. So we just have to choose ln 2 only. And since we have the function already, we have minus ln x equals ln 2. And to get the value of x here, we transfer negative up. So we have ln x to the power of minus 1 equals ln 2. So we have to introduce exponential to both sides, so to get the value of x. So by introducing exponential, we have e to the power of ln x raised to the power minus 1 equals e to the power of ln 2. So when this cancelled each other, so we have only x. So by having x, we have x raised to the power minus 1 equals 2. Then it is obvious that the value of x here equals 1 divided by 2. And here is the solution that satisfies this problem. So we can indeed check for it. So we can test for it from the given problem, which is 4 to the power minus x equals x. So since we get x equals 1 divided by 2, by plug it in, we have 4 to the power of minus 1 divided by 2. So we want to prove that it is equals to 1 divided by 2. So this is very clear. So by considering from here, anytime we have 4 to the power of minus 1 over 2, we can write it as 1 divided by 4 to the power of 1 over 2. Then 4 to the power of 1 over 2, we can write it as 1 divided by square root of 4. And the square root of 4 here is given as 1 divided by 2. It shows that the left hand side of this equation equals to the right hand side. And as usual, we are done with this problem. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and turn on the notification bell for more exciting content. And see you in the next video. Never stop learning. Bye bye.